Hey guys, here's a quick video going over the chi-square test of independence and the chi-square test for homogeneity of proportions. You'll hopefully recall that we just wrapped up the chi-square goodness of fit test, and that was for the situation where we had one categorical variable and one population of interest. The chi-square test of independence and homogeneity of proportions are going to look at two different situations. The tests, the good news is, are ultimately the same. The only difference between the two is how the subjects are selected or randomly assigned to groups, and then that'll affect which test you're doing and the hypotheses and conclusion. But the work's going to be the same for each test. The expected counts will be the same, all that kind of stuff. So the two situations we need to consider are when we have one categorical variable measured across two or more, really, populations. And that's going to be the homogeneity of proportions test. We're looking to see for a particular categorical variable, are the proportions of success the same for all groups? The other test is going to be when we have two categorical variables. I guess it could be more, but we'll say two, across one population, and we're looking to see, are the two categorical variables independent of one another? So those are the two things we need to consider, and that's how you can distinguish goodness of fit from homogeneity of proportions from independence, is how many populations are we considering versus how many categorical variables am I interested in? So my example here is comparing the type of wine purchased at a grocery store while different kinds of music were being played in the store. And I'll go through the hypotheses for both tests. We don't know how we got these people, but we'll talk about how sampling those people would affect which test you would do. The null hypothesis, regardless, is that the groups are the same or the categorical variables are independent of one another, meaning they don't have an effect. The conditions we'll consider are random, independent, and large sample size. So again, not normal. The large sample size is going to be the expected counts, all greater than or equal to 5. Now, if we were considering this data set as multiple groups, say, for example, the group listening to no music, the group listening to French music, and the group listening to Italian music. So in a sense, there were 3 random samples taken, and we looked at the distribution of wine purchased for each of those groups. Then we're considering this one categorical variable of wine and that distribution that was purchased for each of these 3 groups. And if you treat it that way, we're talking about several populations. The shoppers that were listening to no music, the shoppers that were listening to French music, and the shoppers that were listening to Italian music are all considered separate groups, and it's the distribution of wine they purchased that we're measuring. That would be the test for homogeneity of proportions. Alternatively, we could say, over the course of a day, different kinds of music was playing and people bought different types of wine, and we took a random sample of 243 people. From the one sample, we then broke everyone up into this two-way table. Now we're looking at one sample and 2 categorical variables that we're breaking them up into. So that's going to be 2 categorical variables against the one population of shoppers. That would be then a test for independence. So it really depends on the language of the question. How were the people obtained Was it, I took a random sample while no music was playing, I took a random sample while French music was playing, and I took a random sample while Italian music was playing, and therefore it's a test for homogeneity? Or did I take one random sample of people shopping and then filtered them by the type of music that was playing when they bought their particular type of wine? That's the subtle difference in the two tests, which is, it's good news, bad news, because the work is going to be the same. It's just some of the semantics of the test that will change. So once you've identified which of these two tests it is, you would need to find the expected counts, and that's the same regardless of which test you're doing. And then the corresponding degrees of freedom, the calculation of the chi-square, and nothing's going to, from here on out, everything's the same until you get to the conclusion, depending on which test you did. We'll see when we find the expected counts, we'll make sure that they're all greater than or equal to 5. At some point, we would have read that it was a random sample or multiple samples. And then some comments on the independence. If it's homogeneity of proportions, we would want to say that this group is independent of this group is independent of that group. And then the type of wine purchased was also independent. So between the groups and within the groups, we have independence. If you're doing a test for independence, the condition isn't that it's independent. That's the thing we're trying to show. So what you would want to say, if it's a chi-square test of independence for the independence condition, this guy here, is that one shopper's purchase doesn't influence another shopper's purchase, something to that effect. But you wouldn't want to say that the type of wine is independent of the type of music, because that's the thing you're actually testing. Once all that's done, we've checked our conditions. We'll have to find the expected counts, really, to get the conditions locked in. And so the way you want to get the expected counts is, well, I'll tell you in theory what's happening, and then I'll post another video with how do I do that on the calculator really fast. So you'll want to check that out after this. But to get these expected counts, we want to look at these marginal totals out here and say to ourselves, okay, well, if overall 99 out of the 243 people purchased French wine, that's some proportion of people that purchased the French wine, right? 99 out of 243. If that's then, if the groups are not different from each other, then I would expect to get that fraction of wine purchased for this group of none, for this group of French, and for this group of Italian. That doesn't mean that they're divided equally among the groups, because there were 84 shoppers that weren't hearing any music, 75 shoppers that were listening to French music, and 84 that were listening to Italian music. So though I expect this proportion of success, and by success I'm specifically talking about buying French wine right now, I need that proportion to be the success rate for the 84 people who weren't listening to any music. That's how I'm going to get that number right there. The expected number of French wine purchases for people not listening to music. Now that also is going to be the same number for the people that were listening to Italian music. To get the number for French people, it's going to be this same proportion of success, 99 out of the 243. But now we're looking at, there were 75 of those people listening to French music. So it's going to be this product that gets us that number there. So for each of these 9 cells, we need to come up with this set of products. And the expected counts for each cell is going to be the row total times the column total over the table total. And that'll be true for each of these cells. So if I just pull this guy out right here, that's 31 times 84 over 243. The row total times the column total over the table total. That's how you get 10.72. And you're going to need all those values. Now, I do not need you to calculate those one by one on the calculator. I will show you in another video how to get all those numbers in a snap. But once you have, really 4 of them, you can, these 3 have to add up to 99. So if I know these 2, I'm going to know the third one. But you'll definitely lean on your calculators for that. You're also going to want your calculators because you're going to want it to do the sum of those 9 entries. Now that you have all these expected values, I need to find the sum of each observed minus the expected squared over the expecteds. And because it's a two-way table, these numbers are going to be much larger. There are going to be some non-terminating decimals. And you want to lean on your calculator and not round anything because that will change your answer slightly. When you're showing me the work, I want at least the first and last terms of the sum and the chi-square statistic. Once you have the statistic, you're going to go look that up in your chi-square table for the correct degrees of freedom. The degrees of freedom in the two-way tables, which is regardless of its homogeneity of proportions or independence, is going to be the number of rows minus 1 times the number of columns minus 1. In this particular problem, we had 3 types of music, we had 3 types of wine, so 4 degrees of freedom, which, this is a pretty large chi-square statistic for only 4 degrees of freedom. When you go look that up on the table, you'll see that it falls between these 2 chi-square critical values. Therefore, the p-value is between 0.25% and 0.1%, or 0.0025 and 0.0. Let's sneak another 0 in there, 0.001. Surely, you're going to reject at that p-value any reasonable alpha level you would likely reject if this were a test for homogeneity proportions. And again, that's when you're treating them as multiple populations and one categorical variable. Your conclusion would be that we have evidence to reject the null and say that there is a difference in the multiple distributions, right, considering the multiple populations for this one categorical variable, type of wine purchased for the French group, the Italian group, and the no music group. If it's a test of independence and we had taken just one group of people and looked to see was there a relationship between the music they were listening to and the type of wine they purchased, we would say, yeah, we have evidence to say that something's going on here. We have evidence that the type of wine purchased and the type of music are in fact associated, or we've shown that it's not independent. The null would be they are independent. And that's the test. The work you guys will get really comfortable with. Really the nuance of what kind of test are you doing? Is it homogeneity or is it independence? That'll be the thing that trips up most of us, and we'll take a little bit of practice. I'll end this video not by carrying out this test. I'll come back to this one and use my calculator to show the work for this one, but just identifying what type of test this one would be based on the question. And we have a class of 36 students who are polled, and we're giving the following two-way table. So is this a test of independence, or is it a test for homogeneity of proportions? Well, because it was one group of 36, they were then broken up into party preference and gender, this is going to be a test for independence. This is one population, and we're looking to see, are the variables related? Your task is going to be to tackle the rest of the pages attached to this, pages 3 and 4,